Hello, everyone. My name is Salim Audu, as I was introduced. I'm standing in to do this presentation on behalf of my colleagues. And the topic that I'm going to present on is threat modeling and risk analysis of the MOSIP biometric authentication flow. This work was actually founded in part or in whole by the Bill and Melinda Foundation, and that is the acknowledgement. And the next session is about the authors. We predominantly from we had three groups of people: Alan Turing Institute, Carnegie Mellon University Africa, CMU Africa, and the Modular Open Source Identity Platform, which is the MOSIP. So the research overview was to diagnose a threat that are prevalent in the MOSIP system or that exists in the MOSIP system and see how best we can provide solutions or mitigation strategies to it. So on the basis of that, after the work, we realized that there were some key findings that include the system vulnerabilities, then that exist in general biometric identity systems. We also realized that there were some issues specific to MOSIP, and there were also machine learning threats that exist in our work and the governance gaps. So I'd rather go into the main details from here. So at the background, the motivation for this work was the fact that we all acknowledge that identity systems have key issues that needs to be considered and addressed. And it is even more important when you have a system like the MOSIP, which is an open source identity system, because such systems allows for flexibility and it also allows for adaptability. So the MOSIP system architecture even makes it more important. So we decided to do a need-structured analysis and assess the vulnerabilities if some exist. So the research objective was first to identify threats using the threat frameworks that we combined together. So the threat strategy that we used was the STRIDE, the DREAD, and the META frameworks. So the other research objective was to assess the vulnerabilities in the MOSIP system and also to recommend strategies that exist. So on the basis of that, we set up 3 research questions, and they include the following. What are the key security threats affecting the MOSIP biometric authentication, and how can they be systematically modeled and prioritized using the STRIDE, DREAD, and META attack? The second research objective was to identify the vulnerabilities that influence the security and resilience of the MOSIP system, particularly in developing economies. And the third one was the mitigation strategies. How can they be effectively used to address the adversarial machine learning problems and the synthetic identity attacks that exist in the MOSIP system? So to do this, we settled on a methodology where we defined the user journeys and the authentication flow of the MOSIP biometric system. Then using the STRIDE, the DREAD, and the attack strategies, we identified the attack points, then classified the threats that we identified, and mapped them to the common vulnerability and the common weaknesses that exist using the 2020 to 2024 data that we sourced from the national level. Then based on this, we then adopted the mitigation strategies that align with the NIST, CFI, and the DPI frameworks. So the MOSIP system actually, or the MOSIP biometric architecture actually has 3 main key things. That is the actors, the process, and the use of the foundational trust models. So regarding the actors, in the next slide, I will show how it exists, the linkages that actually happen, because the actors are the resident, the authentication partner, then the MISP system, which is a core system. Then the process includes the way they capture the data, how it is encrypted, how it is transmitted, and how it is the deduplication is done using the match. Then on the use of the foundational trust model that is being used in the system, and the zero knowledge encryption tool will be shown in the next slide. So if you look at this, you have a biometric device, which is likely a L1 device, and it is actually signed and encrypted when the data is taken, and it goes through the authentication client. Then the authentication clients have to push it to the IDA service, then the matching is done. So if you look at the numbers, the 1 is a biometric capture process, the 2 is the encryption and the packaging, then the 3 is how the transmission is done, then the 4th one, which is at the zero knowledge encryption, is how the matching is done or the biometric verification is done. So the threat modeling frameworks, as I explained, the stride, the dread, and the meta attacks were used. So on the basis of what we did, we realized that the CVE data analysis showed that digital ID, health, and other data was segregated in terms of digital ID data, health data, finance data. Then we also realized that the top common weakness and mutations that existed in our work were the CWE 285, that's improper authentication, then CWE 863, which is an incorrect authentication. Then there were also issues relating to the attack vector. So in all, when we did all this and showed it with a Sankey diagram, we realized that digital ID systems in general have some risks across all sectors using the case studies that we adopted. So we also looked at the machine learning lifecycle of the MOSIP system and realized that there were some data, some issues from the transfer part of it to the inference and the deployment. So regarding the training, we realized that there were data poisoning and the need for some robustness. Then the inference aspect, there was some model inversion, then extraction. Then on the deployment, we have the API abuse. So using the stride, so we then categorize the results into using the stride part and the dread part. So regarding the stride, we realized that in terms of the spoofing, there were some deepfake injection and hijacked credentials. And regarding the tampering, there were replay attacks. Then regarding the repudiation, there were lack of audit trails and biometric verification. Then regarding the information disclosure aspect, there were template leakages and API exposure. Then denial of service too, we realized there were some overloads of authentication endpoints. Then elevation of privilege, there was the potential for bypass of FTM or matcher threshold. So on the dread, which is in terms of the first D, which is the discoverability, there were some open source exposure and third-party vulnerabilities. And in terms of the reproducibility, we realized there were some attack points that varies and some easily replicable. Then in terms of the exploitation, there were some weak session control, open APIs, and on-LI devices potentially being used. Then in terms of the affected users, it could be on the national scale impact. So then the potential damage, or in terms of the damage, to realize there were likelihood of identity theft and PII exposure, then systematic disruption. So overall, we realized that some of the key threats that were identified in our work included the spoofing, as I explained earlier on. Then there were template leakages and replay attacks. Then in terms of there were also model poisoning and inference abuse. Then the third-party issue clearly indicated that there were some supply chain risks that needs to be addressed. So on the basis of all that we did, we then decided to propose solutions or strategies that could potentially be used to make MOSIP and other open source systems more robust and resilient. So regarding the immediate or the short term, we proposed the incident response where technical people and non-technical things need to be done to ensure that when there is a case of that sort, it needs to be addressed quickly in order to prevent it from escalation. Then there was also the need for patching, encryption, access control. Then we also proposed the need for liveness detection, where at least people cannot engage themselves in deepfakes to run around it. Then, so we proposed that there was a need for liveness detection, multimodal biometrics, then secure SDM and machine learning hardening, among others. So in terms of the midterm, we proposed the need for workforce training, third-party risk management, threat sharing, and the long-term too has to be in a way where AI-driven security is involved in management of open source identity systems, and the quantum resistant crypto can also be used as one of the ways to enhance the robustness of the system. Then policy reforms to align with best practice and international acceptance, stuff that need to be done. Then overall, we realized that things that relate to risk-based authentication and standardization management can be used to at least help in the management of the system. Then cross-border collaboration and DPI governance are also essential in managing issues related to the open source system. So the conclusions we get from that work that we did was that digital identity systems have now become very foundational, where people use it to access services, whether health, financial inclusion, and the fact that people also use it for, so some countries use it for crime prevention and strategies, even though there are some issues relating to that and people have their observations or views about them. So we realized that there was, once it has become foundational and there are some vulnerabilities, they need to be addressed. We also realized that the CWE, that's a weakness, is informed modeling, shows that there were some systemic weaknesses that need to be addressed. We also realized that proactive cross-sector mitigation is critical, and structured modeling enhances resilience. Then security of identity systems also increases the trust that people, or the public trust that someone presented on earlier on. So we recommend the following. Because of the way that the system is open, there is a need for adopting dynamic threat modeling approaches to at least enhance the security of it, because once the system is open for adaptation, that also in itself shows that the attack surfaces too are increased. So attack expansion, and because there is also the risk related to third party, as I indicated earlier on, the open source and heterogeneous devices, that's why we propose that adopting dynamic threat modeling approaches are also important. Then there was also the issue relating to, we recommend that real-time anomaly detection should be adopted because biometric systems face multifaceted problems, and non-LI biometric usage also enhances the vulnerability, especially in uncontrolled environment or low deployment areas. Then we also recommend that there should be standardized benchmark for secure third-party integration due to MOSIP's focus on the hardware integrity. where there exist the supply chain security issues and the SDA variability and cloud-based matching. Then the next thing that we recommend is the addressing of MOSIP's improper authentication or authorization logic flows that was identified, then to make it more resilient and secured. Then there is also the need for MOSIP to address privacy, governance, and socio-political dimensions that were prevalent. So that brings me to the end. Thank you very much.